Okay, so have you ever stopped to think, like, did the Big Bang even happen?
Whoa, right out the gate with a big one, huh?
Yeah, I know it sounds kind of crazy, right? It's like, Big Bang, it's a given, it's how everything started. But I've been reading some stuff, and, well,
It's not so simple, is it? There's some new stuff coming out that's making everyone rethink things.
yeah, exactly. And it's kind of blowing my mind.
Well, before we blow your mind completely, maybe we should, back up a bit. Like, what even is the Big Bang? For anyone listening who, maybe hasn't thought about it since high school science class.
Yeah, good point.
So, picture this. The whole universe, everything, starts as this tiny little point. And I mean tiny. Smaller than you can imagine. And it's hot. Like crazy hot. And so dense. It's
So denser than, like, a black hole?
way denser. It's like all the matter and energy in the entire universe crammed into this microscopic speck.
My brain hurts just thinking about it.
And then suddenly, this tiny point explodes outwards, expanding super fast, like faster than the speed of light fast. That's what they say, anyway. And that expansion, that's what creates space and time. And as the universe cools down, matter starts to form. First, it's just these tiny particles, but eventually they clump together and you get stars, galaxies, planets, all that good stuff.
Okay, so that's a super simplified version, but I think people get the idea.
Basically, the Big Bang is like this massive cosmic explosion that kickstarted the whole universe.
And for a long time, that was the accepted theory.
Totally. There's a bunch of evidence that seems to back it up, too.
Like what?
Well, there's this thing called redshift. Basically, when we look at distant galaxies, the light from them is stretched out, shifted towards the red end of the spectrum.
Okay.
And that tells us that those galaxies are moving away from us. And the farther away they are, the faster they're moving.
So it's like everything's expanding outwards from a central point.
Exactly. And that fits with the whole Big Bang idea, right?
Yeah, it does, but you said there's more
Oh,
evidence.
yeah. There's this thing called the cosmic microwave background radiation.
I've heard of that, but honestly, I have no idea what it is.
It's like the faint afterglow of the Big Bang. This radiation is everywhere in the universe, and it's leftover heat from that initial explosion. It's actually something you can pick up with a really sensitive radio telescope.
Whoa, so it's like we're literally seeing echoes of the Big Bang.
Pretty much.
That's wild.
Anything else?
Yeah, one more big one. The abundance of light elements in the universe.
Light elements.
You know, like hydrogen and helium. The Big Bang Theory predicts how much of these elements should have been created in those first few minutes after the bang.
Okay.
And when we actually measure the amounts of these elements in the universe, they match up really well with the Big Bang's predictions.
So it's like all the pieces of the puzzle fit together.
For a while it seemed that way. But then along comes this fancy new telescope, the James Webb Space Telescope. And this thing, it's looking farther back in time than we've ever been able to see before. And what it's finding is causing some serious headaches.
Okay, here's where things get really interesting. Oh yeah, the James Webb is sending back images of galaxies that are just way too developed, way too mature for their age, according to the Big Bang timeline.
So it's like they shouldn't exist.
Pretty much. It's like finding a fully grown adult who claims to be only a few years old. It just doesn't add up.
Wait, so what are scientists saying about this? Are they just, like, ignoring it?
No, they can't ignore it. The evidence is right there, and it's got the whole field of cosmology buzzing.
So what are they saying then?
Well, there's a lot of debate, obviously. Some are saying that maybe just maybe, we need to rethink the whole Big Bang timeline.
Like maybe things happen faster than we thought.
Yeah, maybe the early universe evolved much more quickly than we originally calculated. Or maybe, just maybe, there were other processes at play that we haven't even considered yet.
Processes that could explain how these galaxies form so quickly.
Exactly. It's like we're missing a piece of the puzzle.
Oh,
Or maybe even a whole bunch of pieces.
okay, this is making my brain hurt again.
Welcome to cosmology.
But seriously, if these James Webb images are throwing everything we thought we knew into question, what does that mean for the Big Bang Theory?
That's the million-dollar question. Is it possible the Big Bang happened, but just not like we thought it did? Or is there something else entirely going on, something we haven't even begun to imagine?
That's wild.
It is pretty wild, and it makes you wonder about, well, the people who've built their whole careers around this theory.
You mean like, what if they're hesitant to admit they might be wrong?
I mean, think about it. There's a lot of money, a lot of research funding tied up in the Big Bang Theory. If you're a scientist who spent your whole life studying it, and suddenly there's evidence suggesting it might be wrong,
Yeah, you might be a little reluctant to throw it all away, huh?
especially if it means potentially losing your funding.
And I mean, I get it. If someone told me my whole life's work might be based on a flawed premise.
It would be hard to swallow. But at the end of the day, science is supposed to be about pursuing the truth.
Right. But what if the truth is inconvenient? What if it threatens the status quo? What if it makes you question everything you thought you knew? Like that song, Liar, by Three Dog Night. I keep thinking about those lyrics. I know you're lying, but I'm still buying.
Interesting connection. It does kind of feel like that sometimes, doesn't it?
It makes you wonder, you know.
Oh.
But for now, let's get back to the science itself. What are some other things that don't quite add up with the Big Bang Theory?
So remember how we were talking about the universe expanding?
Yeah, like everything moving away from everything else.
Exactly. And we can actually measure the speed of that expansion. It's called the Hubble constant.
Okay.
But here's the thing. We get different numbers depending on how we measure it.
Wait, seriously?
Yeah. It's like, imagine you're trying to figure out how fast a car is going, right?
Okay.
But you get one speed if you use a radar gun, and a totally different speed if you time how long it takes to travel between 2 points.
That's super weird. So, like, which one's right?
That's the million-dollar question. We have these two main ways to measure the Hubble constant.
Okay.
One uses observations of stars and galaxies to kind of build a measuring stick across the universe.
That sounds complicated.
It is. But the other way uses the cosmic microwave background radiation.
Oh, right, that afterglow from the Big Bang.
Yep, exactly. And both methods are super precise, but they give us different answers for how fast the universe is expanding.
So what does that mean?
It means something's off. Either one of our measuring methods has some kind of hidden flaw we haven't figured out yet, or, and this is the really crazy part, our understanding of how the universe is expanding is totally wrong.
So basically, more evidence that something isn't quite right with the Big Bang Theory.
Yeah, it definitely adds to the pile. It's like, okay, we've got these early galaxies that shouldn't exist. We've got this weird problem with measuring the expansion of the universe. Is there anything else?
Haha, yeah, are we done yet?
Uh-huh. Oh no, there's more.
Bring it on.
Okay, so the Big Bang Theory, it makes these really specific predictions about the cosmic microwave background radiation.
You mean like what it should look like?
Exactly. It says that the radiation should be like perfectly smooth and evenly distributed across the entire universe.
Okay.
But when we look at the actual data from, like, the Planck satellite, it's not perfectly smooth. There are these tiny little variations, these fluctuations in the temperature of the radiation.
So the universe has, like, cosmic hot spots and cold spots.
Yeah, you could think of it that way. And these fluctuations, they're not huge, but they're bigger than the Big Bang Theory predicts they should be.
Okay. So that's not great for the theory.
Not really. And then there's the mystery of the missing lithium.
Missing lithium.
Yep. The Big Bang Theory says how much lithium should have been created in those first few minutes after, well, the Big Bang.
Yeah.
But when we actually look at how much lithium there is in stars and gas clouds, it's way less than what the theory predicts.
Okay, so it's like the universe is missing some of its lithium.
It really seems that way, and nobody's quite sure where, when, or why it wasn't created in the first place. It's a real head-scratcher.
Yeah, it's like the more we learn about the universe, the more questions we have.
Isn't that the truth? It's kind of like every time we think we're getting closer to the answer, the universe throws us another curveball. But that's what keeps it interesting, right?
Yeah, I guess so. But at this point, I'm starting to wonder if maybe, just maybe, the Big Bang didn't happen at all.
Whoa, hold on a second. That's a pretty big leap. I mean, yeah, there are problems with the Big Bang Theory,
Yeah, I'd say so.
but it's still the best explanation we have for a lot of what we observe.
Okay, so you're saying we shouldn't throw out the whole theory just yet?
I think it's way too early for that,
Yep.
but we should be open to exploring other possibilities.
Like what? What else could explain all this stuff?
Well, there are some alternative cosmological models out there. Some of them are pretty out there, admittedly, but some of them are actually pretty interesting.
Like what? Give me an example.
Okay, so one idea is something called the cyclic universe model.
A cyclic universe.
Yeah, so basically, instead of a single Big Bang, this model suggests that the universe goes through these endless cycles of expansion and contraction. So, like Big Bang, expansion, then a big crunch where everything collapses back in on itself, and then another Big Bang.
So it's like the universe is breathing, expanding and contracting over and over again.
Yeah, kind of like that. It's a mind-bending concept, but there are some physicists who think it might actually be how things work.
So wait, if this cyclic universe idea is right, does that mean the Big Bang wasn't actually the beginning of everything?
Exactly. It would just be one stage in a much, much larger process.
Wow. Okay, now that's really blowing my mind.
It's wild, right? And it makes you think, what else might we be wrong about?
It's like that Three Dog Night song keeps playing in my head.
Liar.
Yeah. What if everything we've been told about the universe is just wrong?
Well, I wouldn't go that far just yet. It's definitely a trip, right? Thinking about all these different models and possibilities for the universe.
Yeah, it's like my brain is kind of fried right now, but in a good way. Like, it's just so amazing to think about how much we still don't know.
Totally. It's humbling, for sure. And exciting.
Yeah. It makes you realize that we're just at the beginning of understanding how all this stuff works.
Oh, yeah. We're just scratching the surface.
So, like, what do you think the future holds? What kind of crazy discoveries might be waiting for us out there?
Ooh, that's a good question. I mean, who knows, right? But if the past few years are any indication, I think we're in for some wild ride.
Yeah, with the James Webb sending back these mind-blowing images.
Exactly. And new telescopes are being built all the time, even more powerful than the James Webb.
So we're just going to keep seeing further and further back in time, learning more and more about the early universe.
Yep. And with that, I think we're bound to find more things that challenge our current understanding of how things work.
Like, maybe even more evidence that the Big Bang wasn't the beginning after all.
Maybe. Or maybe we'll find evidence for something even crazier. Like, what if there are multiple universes out there?
A multiverse. Whoa.
Or what if we discover some completely new laws of physics that we never even knew existed?
Yeah, okay, now my brain is really melting.
Haha, I know, right? But that's the beauty of it all. There's always something new to discover. There's always another mystery to solve.
It's kind of like we're all cosmic detectives, right?
Exactly. Looking for clues, piecing together the evidence, trying to understand this vast, incredible universe we live in.
And sometimes, maybe we gotta be a little skeptical. Like in that Three Dog Night song.
Liar.
Yeah. Sometimes you gotta question what you're being told, even if it comes from the experts.
That's true. Healthy skepticism is important in science. We always have to be questioning, always be testing our assumptions.
Because the universe doesn't really care about our theories, does it?
Nope. It just keeps doing its thing.
And we're left here trying to make sense of it all.
Exactly. But that's what makes it so much fun.
I think that's a good place to wrap things up for today. It's been amazing talking about all this, even if I do feel like my brain is a little bit scrambled.
Uh-huh. Mine too. But hey, that's what happens when you start digging into the mysteries of the universe.
To everyone listening, thanks for joining us on this crazy cosmic adventure. And until next time, keep those brains buzzing, keep questioning, and keep looking up at the stars.